Hi everyone, and welcome to our new live webcast, OPC Ua Security, Native and Add-on Solutions for the Rise of Smart Factories. My name is Daniela Previtali, the Global Marketing Director for Wibu-Systems, and I am delighted you are here with us today. We are joined by Thomas Burke, President and Executive Director of the OPC Foundation, and Oliver Vincent Reed, CEO and founder of Wibu-Systems. The mission of the OPC Foundation is to manage a global organization in which users, vendors, and consortia collaborate to create data transfer standards for multi-vendor, multi-platform, secure, and reliable interoperability in industrial automation. Wibu-Systems is a global leader in software protection, license lifecycle management, and cybersecurity solutions that has been supporting the monetization process of software publishers and intelligent device manufacturers by providing versatile, scalable, and multi-platform technology against piracy, counterfeiting, reverse engineering, and tampering. Today, our hosts are going to talk about the elements of innovation of smart manufacturing, the connection requirements for M2M in the IoT age, the building blocks of the OPC unified architecture, use cases that are accelerating the rise of smart factories, the integration of CodeMeter in the OPC Ua standard, and the OPC Ua security extension for endpoints. Some housekeeping we need to take care of before we start. For everyone who is joining us today, I want to remind you that we will be reserving some time at the end of the session for Q&A, and I'd like to invite you to submit any question you have in the live chat room. This session is being recorded, and a link to the replay will be posted directly to you in a couple of days. Without further ado, I'll pass things over to Oliver. The floor is yours.
Yeah, thank you, Daniela, for the introduction. Welcome everybody to our webinar. Welcome Thomas, and thank you for joining the webinar as panelist. You will give us and our participants an introduction about OPC Foundation, the OPC Ua standard and architecture. In the second part, I will show use cases in smart factory projects where Wibu-Systems is involved, adding security layers to OPC Ua implementations, as well as how you, dear participants, can benefit and implement security in connected products with CodeMeter. Last part will be the Q&A session as announced by Daniela, and we will be very happy to answer your questions. So it's your turn now, Thomas. Please go on.
Thank you, Oliver. This is a very exciting opportunity working with Wibu-Systems, talking about the OPC Ua technology and what's been going on in the world. OPC is really all about industrial interoperability. And what I want to talk about today is what we're doing specifically. We're talking about moving data and information from the sensors to the cloud and the importance of multi-platform, secure, reliable interoperability in a multi-vendor environment. So when you think about this from a business perspective and what everyone's thinking about now, everyone's thinking about the whole concept of IoT and the value of the industrial, or the Internet of Things, and what are the things that you can do with it in terms of connectivity and data. I see every day so many new IoT type devices out there in the consumer world that are really changing the world. Things like a water bottle that reminds me on a regular basis that I should be drinking more. Things like improving, the ability to play sports, including tennis. It's all about the connected world of data in the IoT world. You have all this information at your fingertips, and you're able to take advantage of this. And this is really beginning to drive the whole world in terms of the industrial Internet of Things. You take a look at what the consumer IoT is about, and then you start taking a look at the industrial Internet of Things, and you think about all the potential devices in the industrial world, and the volume of them is huge, even more So then in the consumer world, we're talking about, literally billions of devices that potentially would be connected, and you'd want to have access to the data and information from. So this really is changing the world. And with the efforts that are going on in the industrial Internet of Things and the M2M and Industry 4.0 that I'm going to talk about and the Industrial Internet Consortium, we're seeing a whole driving force essentially where people are looking for, the ability to leverage standards for multi-vendor, interoperability. With OPC Ua and, the alignment with Industry 4.0 and China 2025, we're seeing a whole focus at people building what's known as an SOA, or called a service-oriented architecture, where you want to have these devices and applications be able to be seamlessly connected. They want to provide services. You want to have the ability for an application to be able to connect up this device and discover what are the, the services and the data that the device offers, so you can take this thing, in a plug-and-play fashion without writing custom software for interoperability. So, with all the connecting things and how you want to have data and information integration, everybody's looking for interoperability. Everybody's looking for the ability to, model their information, look at their information, and move it from their connected devices, into other applications and then into the cloud. And then when you're thinking about all that, security really becomes the fundamental component of the infrastructure that must be handled. You want to secure your data. You want to make sure that it's, encrypted and authenticated, and the people that need to access it, can access it, and people that shouldn't be able to access it can. And this is an important partnership that we have with Wibu-Systems and the work that they are doing, developing, really streamlined products that really address, the whole market and need for security, and it lines up very well with exactly what we're doing with OPC Ua. So from an OPC Foundation perspective, I've been doing this since a long time, but we see that there's a lot of movement from the world of where OPC was in 1995 until 2016, but the vision has still always been about, secure, reliable, multi-vendor interoperability. Now we're really talking about multi-platform. We're talking about, moving data from the embedded world directly into the enterprise. And again, this is where Wibu-Systems is going. They're building the products that really enable interoperability. From a membership perspective, the foundation really has significant growth in Europe. The European market is actually well ahead of adopting standards for a lot of reasons, in comparison to the rest of the world. But, we're seeing widespread adoption of the technology in both, in the OT world and the IT world. I actually have offices inside of, the U.S. in Arizona. We have an office in Germany, we have an office in China, an office in Japan, and essentially these are organizations that are fundamentally part of OPC that are really pushing and, facilitating adoption of the technology into all these markets where everybody's looking for interoperability. We've just announced that we're going to form, and we've started an organization in Korea, and also I plan to operate and start an organization in India. So if you think about what I'm talking about, I'm really talking about, connectivity and interoperability and information integration. We're seeing a very big push, and has been for a number of years now, with Industry 4.0, where essentially they're defining a platform of interoperability where, the end users in a variety of industries are all expecting multi-vendor interoperability, and they're all expecting secure data transfer. The Industrial Internet Consortium has been formed in the, the U.S., but it's also very international. And then there's an organization opportunity in China called China 2025, which again is basing a lot of the principles that are going on in the IIC and Industry 4.0, where everybody's looking for more streamlined interoperability and taking all the principles that we're learning from the consumer world and really modeling it into, the industrial Internet of Things. The reference architecture of Industry 4.0 essentially has standardized on OPC Ua and specifically the IEC version of the OPC Ua specifications as the solution for Industry 4.0. Many of the collaborations that we're doing, and I'm going to talk more about them later on, are also part of that. And OPC Ua partnering with these other collaborations really forms the whole infrastructure for information integration from the embedded world to the cloud. From a security perspective, the German Federal Office for Information Security essentially analyzed the OPC Ua specifications and the reference implementation, and they essentially came out with that, you know what, OPC Ua is the only communication technology for the factory that really provides the implicit security and addresses the challenges posed by Industry 4.0. And they've said that OPC Ua is the answer that they want to standardize on for security for Industry 4.0. So if you look where we started and what OPC Ua does, in the old days, you had to do things very proprietary. You had to write custom software to be able to interface to these factory automation and process control devices. You know, it was complicated. As the device changed, you know, you had to update the software, and it was just a constant, ever-ending scheme where you had to continue to write and maintain software to have connectivity to these devices. It took away from what you really could do with the devices. With OPC Ua, and being its platform independent, you can write one of these things that are called an OPC Ua Server. It understands how to talk to the device from both a connectivity and information strategy, and then it can generically allow a OPC Ua client, which is known as the unified architecture, to be able to connect up to this thing and discover and be able to consume the data, you know, on a PC platform. With what OPC Ua has also done from a scalability perspective, we're seeing a lot of vendors now that, you know what, they decided, well, UA is small. We can do what we need, and we can actually embed it in a device directly, even providing better reliability, eliminating a point of failure, and giving more streamlined access to the data and the metadata behind the scenes. So when I talk about some of the highlights or importance of OPC Ua, I always talk about data connectivity, where we're really looking at, you know, a variety of different platforms, a variety of different operating systems, and really leveraging the connectivity standards and the protocols to really assure and provide a complete interoperability platform independent of the devices, the operating system, and all the different ways that we have to deal with things. So it's an abstract architecture that allows true plug-and-play interoperability. I also talk about the data context preservation, and this is the whole concept of, you know, a generic application can take a look at and can discover the data model and the information and the behavior of the underlying devices and application, and without having any prior knowledge of the information, it can actually have connectivity and read and write the data directly, because the syntax and semantics of the data are provided through the discovery pool that OPC Ua has built into the architecture. And that becomes very significant as, you know, new devices roll out. The client applications, you know, don't have to worry about changing. You know, they can still have complete connectivity and be able to discover and use this data later on without them ever having to, you know, rebuild the application or redeploy the application. So this is a significant step if you're really thinking about interoperability. I call it timeless durability for lots of reasons. So we've preserved people's investment for a long period of time. Security, and we're going to have a great presentation by Oliver, and the importance of security and the products that Wibu offers really, you know, underlie the whole concept of security and building security directly into the architecture and providing the most secure platform, you know, based on all the latest standards that are out there. And security keeps changing, and between OPC Ua and Wibu-Systems, I see a really strong, you know, infrastructure being laid out that as new things change, we're protecting the investment of the devices and application that use the fundamental security principle that built in. And it's been accepted by, you know, the IT and the OT groups, you know, truly addressing the fundamental issue of we've got to make everything secure, it's got to be authenticated, it's got to be encrypted, you got to have the ability of having the data essentially secured, so who can access and who can't access, and that has to be built in the base architecture. So with OPC Ua and the work with Wibu-Systems, you're going to find out that we've solved this problem for you fundamentally. UA has been well accepted by all the security organizations from an international perspective, and we'll continue to work with these organizations to guarantee that we provide the best secure platform. So the architecture of OPC Ua is really all about security and platform independence. We've got what I call a meta model, which is all the rules for exposing the information with OPC Ua. Built on top of that is the base architecture of what the classic OPC specifications were for data, alarming, and history. And that builds right in. So OPC Ua is really both a communication protocol and a strategy for information modeling and information integration. And that's a big step forward that really provides a complete framework for people moving information directly from the sensors to the cloud. With what we've done in our collaboration with over 30 organizations right now, we allow them to build what's known as companion specification, and essentially, OPC Ua provides a mechanism for discovery and moving the information when the domain experts that are in these different, organizations provide the information model or the what. And then this builds right into the OPC Ua architecture, really allowing a complete mechanism for secure information integration between disparate applications and devices. The base premise of OPC Ua is to use what's known as our client-server communication model. That communication model really allows the ability to have multiple protocols built in, and the beauty of this is as applications continue to develop, applications are deployed into the field, OPC can continue to add new protocols, because what we know today is that the technology tomorrow is going to be different, and you've got to have an ability to really protect the investment of all these devices and applications, supporting new protocols, right out the gate. So that's a big thing that UA is built into it. In addition to that, to address the whole, industrial Internet of Things market, we recognize the need for what's known as our publish-subscribe architecture. So we have both client and server and a generic publish-subscribe information model that really provides a way to address communication in the IoT world. And currently right now we're evaluating and adding more protocols deliberately that really provide, seamless interoperability over the various IoT protocols. AMQP we've already built in. We've built in our own UA Secure Multicast. We're adding MQTT right now. We're adding DDS. And we'll continue to add more protocols, essentially allowing even more and more connectivity in this, ever-changing world of, technology, and allowing seamless interoperability. So when we started OPC Ua, it was in 2003. We released our specifications. There were many products that started rolling out. It's an IEC standard, and it's all focused really on platform independence and really leveraging a complete architecture that allows, information modeling in a secure fashion. You're going to learn a lot about what Wibu-Systems has done with this. And again, this is very important if you're really looking for, changing the world and being able to take advantage of this wide exposure of data and being able to use it in an intelligent fashion for information. So UA's got a transport protocol built into it deliberately. Yes, we provide very high performance. We provide, what's known as stacks built into the architecture, which handles a lot of the base functionality that all of our vendors need for interoperability. And I talked a little bit about some of the things that we're doing with, new IoT protocols, and we're going to continue to extend and provide even more functionality as time goes on in the areas of communication and in the areas of continual information modeling. So I like to say that OPC Ua is more than a protocol. Again, I talk a lot about data modeling, the ability to have, a complete system out there where you can have connectivity to all types of different applications and devices. The collaboration we're doing, I can't even keep track of how many organizations have an information model and that they want to partner with us and they want to build UA companion specification to take advantage of the secure, rich security or SOA architecture that we have in place, and this is very important. There are many new applications and use cases. Some of the collaborations that we're working on, specifically in automation, in building automation, in oil and gas, and transportation, it's a whole world where people are really looking for, I've got something that I'm doing in a particular market. There's an existing standard out there that we want to leverage their information model. And these are all the organizations you can see on your screen that we already have partnered with. We have already, either released or about to release companion specification that allows vendors to build products with OPC Ua and this companion standard, allowing this data to be really passed, seamlessly across boundaries and into new spaces. So you'll see a whole focus of it. I can take an industrial automation environment and I'll be able to connect it to my building automation system. And that's really what's important. I really want to be able to have all this connectivity and be able to use this data, but use the data as information in an intelligent way. And that's what OPC Ua does when we collaborate with these other organizations. I talk about adoption of OPC. Is it real? Well, as of the middle of this year, we know that we already have close to 4,200 companies that are already building OPC products, okay? And that's significant. So, we have to maintain timeless durability. We have to have, preserve the architecture and allow new technology innovation change and still preserve the ability for all these companies that are building OPC products to be able to have a strong foothold in the market. The number of products out there well exceeds 35,000, and we know that we've got a minimum of 47 million, plus installations of OPC. And now with the whole rolling out of the IIoT and what we're doing with Industry 4.0 and the IIC, the amount of devices out there that, is even going to continue to accelerate, widespread adoption and installations of the OPC Ua architecture, because literally there are millions of devices out there in the industrial world that our vendors are going to enable with the OPC Ua technology to essentially get data out of this in a discoverable, generic way. There's a lot of videos that are on the OPC Foundation website. There's a picture up here that's, one of the 90-second videos out there that gives a quick overview of what is OPC Ua. And it really gives you the ability of like, well, I want to learn about this OPC Ua stuff and I want to know where to go. So I've built a whole repository of videos. The other thing is, we're getting commitments from all the majors and everyone else, right, that they talk about what they're doing with OPC Ua and why OPC Ua is important to them. And again, you can find that on our YouTube channel. We do a lot of OPC presentations and work at trade shows. This happens to be the Microsoft booth at Hanover this year, where Microsoft was talking about their OPC Ua integration into Azure. This is one of these things where it was a constant flow of people that they all wanted to learn about OPC Ua and learn why Microsoft was standardizing on the technology. So this is one of literally hundreds of things and opportunities out there. We've built some flyers and things that you can find on our website. This is one that talks about the digital factory, and it really talks about what we're doing with Industry 4.0 and why Microsoft has standardized on OPC Ua, integration directly into the Azure cloud. We've got a brochure that's available on our website you can download. It's in multiple languages for a reason. It's got all the testimonials. It talks about a lot of our collaboration, and it provides kind of a framework for really getting started from both a end user and supplier perspective on using the OPC Ua technology. So if you remember anything of what I've talked about today about OPC Ua, It's really what we consider the solution and infrastructure for the Internet of Everything. So whether it's M2M, Industry 4.0, the Industrial Internet of Things, it's providing the complete infrastructure for multi-vendor, multi-platform interoperability and information integration from the embedded world directly to cloud. So for more information about OPC Ua and why it's the worldwide accepted standard for the Internet of Everything, check out the website at www.opcfoundation.org. I encourage you highly to take a look at the products and offerings that Wibu-Systems have and how they're embracing the OPC Ua technology. And with that, I'm going to turn it back over to Oliver, and he'll go into the details of what Wibu's doing with OPC Ua.
Yeah, thank you, Thomas. Thanks a lot for your excellent overview of the OPC Ua standard and architecture. So let me now start with the introduction of some smart factory projects where we are involved. So I will talk today about 4 different ones, about OpSit, about SmartFactoryKL, about Secure Plug and Work, a project under the lead of Fraunhofer IOSB, and IUNO, the German National Reference Project for Cybersecurity in Industry 4.0. So let's start with the first project, OpSit, that's in the healthcare industry. And what has been done here is that there have been things in general to do is to make sure that the patients are using their pills, what they need to do, and that is done with electronic blister dispenser. So the blister roll with the tablets inside is created by a pharmacist, then it comes in an electronic blister dispenser, and here the patient is taking off his medicine, and that is automatically, he gets information on a smartwatch or on another device, and it's automatically reported with a gateway to the care cloud. The care cloud is running an OPC Ua historian in the cloud, and the gateway is transmitting this information securely, so that is shown in that picture. The participants in that project have been the University of Berlin, Fraunhofer, Ocean, who is providing the energy harvesting technology for the blisters and the gateway that can run without batteries, and us and Swisscom as a manufacturer of these blisters and so on. So OpSit takes, the abbreviation comes from optimal use of smart item technologies in healthcare, and what we did is we used small Intel Edison single board computer as a gateway, and we integrated an OPC Ua stack into that, and the whole cryptographic keys for the secure transmission of the data as well as the application code for the Intel Edison single board computer is on a small micro SD card with our CodeMater smart card chip in it to store the cryptographic keys. So a second project that's then not healthcare, this is really Smart Factory, and this is done in SmartFactoryKL. SmartFactoryKL is a technology initiative driven by DFKI, that's the German Research Institute for Künstliche Intelligenz, for KI, and that started in 2002, a long time ago, long before anybody talks about Industry 4.0. But the vision of Industry 4.0 was coming then later, and the SmartFactoryKL has been very well prepared. So there are many members in the SmartFactoryKL. Internationally, there are German ones, there are US ones, there are from all over the world. Small companies, medium-sized companies, and large enterprises like an SAP or Continental, Belden, Huawei, IBM, and so on, you can see on this slide. So what did we do in SmartFactoryKL? We integrated security in a key finder production system. The two pictures on the right show this sample machine, and in this sample machine the raw material. So in fact, this key finder, which is shown in the top, carries its information how it shall be produced and which are the next production step for the raw material in it, and that is stored in an RFID tag. So RFID, if you are using low-cost RFID tags, is not secure against changing, manipulation, and so on. So that's the first part of the contribution from Wibu-Systems. We took care about signing the RFID data in that tags, and then checking the signature can be done in the RFID readers, checking the signature and checking the integrity of the production data. That's the purpose for that. Can be done with tablets or smartphones on the shop floor in an easy way at any time. And the next thing we did inside of this key finder demo machine, demo assembly line, there are many components connected with using OPC Ua, and there are some small, you can see that on the picture below, DigiKey components used with network connection, either wireless or with cable, with an OPC Ua server included, and the keys and the certificates for that are stored in a secure way, in a secure element coming from us. And on the other side, in the cloud, the OPC Ua client can use this data and be sure that the data integrity is there, and that the data is really coming from the right location. So that's the purpose in that key finder production system at DFKI. The next project is called Secure Plug and Work. That's funded by the Federal Ministry of Economic Affairs and Energy in Germany, and there are many participants. So there are many really, what's often not the case, there are many companies that really use the technology and integrate it in the machine. So not only providers of the technology, but also users of the technology. So, and what was the main purpose here? So if you look on that picture, different machines communicate with each other and communicate with the control system or control room above. So so far, if you see the picture like it is, with a MHE grinding machine, with a robot and so on, there's no security involved. So the first step is, if we look deeper into these devices, the arm of a robot uses a PLC and servos. The grinding machines uses a PLC as well and can use different tools and options. All single components need to be configured when putting into service. For example, calibration of robot arms, quality data of ball screw, motor parameters of the spindle, and more. So in the next step, we integrated a vendor-independent communication layer based on OPC Ua, plus some automation ML semantics, and now the system can configure itself. The components deliver their configurations and their data to their PLC. Any operation data, hours of operation, temperature profiles, revolution speed will be recorded and provided using OPC Ua. The challenge now, the machine vendors and factory operators must ensure that all data is coming from trusted sources. Recorded operating data must not get into wrong hands. Therefore, Wibu-Systems has integrated its CodeMeter technology into the OPC Ua stacks running on the different components. It ensures security for the keys and certificates, and so data integrity and trust for the system. So you can see on the slide that we added the security and secure key storage on all the different locations into a secure device that is here shown like a USB key. So that's the Secure Plug and Work project in short, and it, at the end it increases the efficiency of the operation of a factory a lot with like plug and play in USB. You can really plug and work components in machines, exchange components in machines with a secure and full automatic configuration and installation. So the last sample project I want to explain here a little bit is that reference project Security in Industry 4.0 from the Federal Ministry of Education and Research in Germany, that is based on 4 large test beds. One is secure processes for customer individual production, and I will show that in detail a little bit more. A technology database, secure services like remote service, remote access, and visual security control room for production scenario. So let's, the participants in that project, it's a large project, so there are 21 participants, 14 companies, and 7 research institutes working in that reference project for Security in Industry 4.0. It's now about half time. It has in totally there's a 3 years runtime of this project, and the reason why the ministry did this project in that way with the 4 use cases driven by 4 of the large producing companies, that is Bosch, that is Homag, that is Trumpf and Volkswagen, is that these companies are committed not only to participate in research and development and a demonstration, but really to integrate the results of that project in their own factory, in their own production, so that it has a much, much higher impact for practical use and later application in other use cases. So let me come to the first project. The first use case of IUNO, that's this customized production. You see that in the, for example, in the furniture industry, for kitchens or other type of furniture, where we have a full digital electronic, digitized production system from the sales to the CAD design and the order, the planning, then the production, going into the production, and within the production then doing all the steps necessary to create out of wood plates then the finished furniture, like cutting the wood, separating it, doing the etching, sorting, drilling, and the assembly of the furniture. So the goal is in that working package to get a definite and secure identification through the production process. And just to show you the challenges, if you have for example, an RFID sensor on a wooden plate, and you cut the plate into 2 pieces, you have the problem that you have then 2 pieces. Either you have no identification anymore, or you have it only on one, but you can't have it on both. If you do something else like identification with barcodes, you get the problem with cutting as well, or with painting and something like that, so that you can't read it anymore. Next step, of course, is security. It's very important to keep the data and the identification of the material secure. And that further challenge is that you have cross-domain, you need cross-domain trust in the identification process, because it's not only within one machine, so creating from more or less the wood, the bare wood to the packaged furniture, there are several stations and maybe several different factory locations involved. So a cross-domain trust and identification process is another thing necessary. And here in that case is RFID technologies are used, OPC Ua is used for security and identification of this networked devices. Okay, the next use case is a marketplace for technology data. Technology data is data that is necessary to produce something in a machine and to do it in a high quality, in a high speed for different kind of material. For example, you want to laser cut steel with a certain composition of the steel material that is 20 millimeters thick. So how is the settings for the machine to do that in the best way? So today this technology data is normally coming as samples from the machine manufacturer for some materials, for some operations. But in many cases, this technology data needs to be evaluated by the operator, by the user of the machine in the factory. And that means that he needs several days of evaluation time during this time he cannot use the machine for production, so that is a really high cost. If he gives that to a third party, it's more or less the same. And so there is really a need for such technology data. And the goal of this working package in IUNO is to create a marketplace for that technology data so that many participants can contribute their technology data and many operators can really use that, and that it can be electronically done. So goal is easy and secure tradable technology data. Today, as I told before, there's something included in the machine, but there's not technology available to protect this technology data, and there is no marketplace existing. So that's what's the goal: create really a marketplace that fulfills all these requirements. So security, one important step. The third work package in that project is remote maintenance, and yeah, the picture shows a little bit maybe the challenges, and you can think that remote maintenance is something that is easy because all the secure access mechanisms are available, like VPNs and public key infrastructure to give the rights to a service technician. But in practice, it's not so easy. If you are looking in a factory, you have their machines from a machine vendor, for example, from Trumpf, and Trumpf wants to connect this machine to its maintenance platform. But there are service technicians from third-party companies. There are service technicians from the factory operator, like, for example, a VW, a Volkswagen car manufacturer. So they don't belong to the same PKI. So it's not so this to do this remote maintenance use case in a secure way that is also easy to handle is really still a big challenge. Huh? So secure and unified identification of all participating parties, platforms, machines, maintainers, and so on is something challenging, and the routing of connections as well, because the configuration for the network equipment on the shop floor needs to be easy, needs to be in a way that it can be controlled. So another use case where technologies like OPC Ua will help and will be used. All right, so far with this best practices or test beds, I hope that I have shown the requirement for security and the usefulness of the use of OPC Ua for this in this best practice cases. Let's now come to the part to show you how you can implement security in your products and how Wibu technology helps you to reduce costs, time to market, and open new revenue streams with licensing as well. So what is our technology? In the heart of the Wibu key technology, the CodeMeter technology is really the secure storage of keys. And that can be done in small hardware-based devices or as a software-only solution. The devices or the according software components are then handling the DNA encryption for symmetric encryption, for asymmetric encryption, and they can store flexible license models. That means nothing else than you can define how these cryptographic keys can be used, and you can count how often, how long, you can define period of time or something like that. So the second part of our offer are the tools for integration into the software. There's a protection suite that can be used to protect data and program code, and there are libraries that support applications like Secure Boot and also the integration in OPC Ua SDKs so that the CodeMeter containers can be used as a secure key storage for the certificates in OPC Ua. I come to that in a few minutes in more detail. And of course, very important as well, the back office integration. That means the creation of keys and certificates and licenses, the deployment of the licenses, and the administration, which is important as well. So that is, in very short, the technologies we offer. Coming back to OPC Ua. OPC Ua provides high security in transit. This just as a remember to the presentation of Thomas, who did that show that much more in detail. So to do that, there are certificates used, there are today ISA public-private keys used, and symmetric encryption is used for the encryption of the data itself in the secure channel. So Opc Ua, also shown from Thomas before in his presentation, get wide support. So it's supported by the platform Industrie 4.0 in Germany. It's in different standards and recommendations contained. The German Office for Security in IT, BSI, did a study on the Opc Ua standard and analyzes, evaluates the security of Opc Ua. IIC in the US gives a strong support to Opc Ua, and even the Chinese Alliance Industrial Internet is accepting and working with Opc Ua. So that's wide support is a great thing. So what can Opc Ua do in case of endpoint security, and where are these endpoints? So if you are looking in the IIoT landscape, so the endpoints, of course, that's what everybody can think about, is that they are in a sensor, that they are in a drive, that they are in a robot, so in the devices at the edge. But we would call an endpoint as well in the computational network. We would call a device or a cloud service in the Azure cloud or wherever in cloud services, as well as an endpoint. So the endpoint is everywhere where data is received or sent. Not only devices, but of course the devices as well. So you have it on all these positions. And Opc Ua offers excellent endpoint security. Here I added a graphic from Industrial Internet Consortium's IISF security framework document about the endpoint protection and the different topics that all belong to the protection of an endpoint. So access control. I have highlighted in orange the points that really can be helped by Opc Ua, like access control, integrity protection, identity, root of trust, physical security, if you store the cryptographic keys in a secure element, for example, in CodeMeter, data protection, security model, and policies. So that's something, details on this view and different views as well can be found in the Industrial Internet Consortium Security Framework paper, which is publicly available on their website, and I really recommend to have a look into that. So endpoint security is more than a communication and protocol, so it goes beyond the protocol layer. So vulnerabilities in the operating system, software libraries, applications are equally important than the communication. And the consequences if an endpoint is compromised, doesn't matter if the endpoint is in the cloud or in a sensor, is really the theft of the cryptographic keys, which means if somebody can get the private key out of a sensor, he can then create an unlimited number of other sensors, and because he has the cryptographic private key, they can authenticate as the other one and completely corrupt any system integrity, and they can simulate to be a sensor that they are not. So that is something that is a consequence if an endpoint is compromised. The manipulation of configuration data, of course, is possible then as well. Trust lists, certificate revocation lists, if they can be easily accessed, and the manipulation of the application. So this security requirement is really additionally to the communication. And how do we use Opc Ua as an open standard? Offers all the security features, but the implementation is then the responsibility of a manufacturer of a device, of a PLC, of any endpoint. So, and in many cases today, the private keys are stored simply on the flash disk or hard disk of or in the memory of a sensor, of a PLC. The trust list, certificate revocation lists is in the same, and the applications are not protected. So that is really a risk. And as I told before, successful attack to an endpoint can give further penetration to the infrastructure, can give a loss of functionality or reliability, intellectual property, and can do identity thefts. So here, CodeMeter with its different components comes into the game. So there's a modular runtime system for embedded systems called CM Embedded that is portable to a variety of operating systems, and it provides a subset of the complete CodeMeter API. It can then support the CodeMeter dongle that is based on a smart card chip, a security controller from Infineon Technology, certified to common criteria EL5+, that allows a highly secure storage of cryptographic keys, the secure execution of the crypto operations, and these secure hardware components are available in a variety of different form factors, for example as a chip to directly solder into a sensor device, or as a removable micro SD card that has additional to the flash memory the secure element. So then in the next step, the CodeMeter embedded is integrated in OPC Ua SDKs. So that makes it easy to use to create a OPC Ua application without a big effort and development effort to do anything, to take care anything about the storage of the cryptographic keys. So the access to protection, licensing, and security features of CodeMeter will become very easy. And what is now enhanced with CodeMeter in OPC Ua? So first of all, the cryptographic keys, the private keys, are stored in the secure hardware in the CodeMeter dongle part. So extraction of the private keys is practically impossible, or the effort to do that is very, very high. Second, other sensitive information is protected as well, like for example trust lists, revocation lists. The whole OPC Ua application in a sensor, in a PLC, in a device can be protected and prevented against tampering and reverse engineering. And signatures for protected information are then verified in the CodeMeter dongle. So that gives a much, much higher level of security with a relatively easy integration of this technology. And CodeMeter offers something more with OPC Ua, and that is the advantage that you can configure different features of your application, OPC Ua application, with the CodeMeter licensing. And this is no extra cost and no extra effort, because if there's CodeMeter already integrated in the OPC Ua stack, in the OPC Ua application for storing of the cryptographic keys for OPC Ua, it's quite easy to use it for licensing as well, so that you can configure which features in a device can be used in your device and how they can be used. You can create new license model business models. That's a big advantage. And further advantage is the update of this configuration and licenses in a dongle. Of course, you don't need any physical access. You don't need any additional network protocol or open ports. You can distribute the configuration of these license features through your OPC Ua. So this activation of features or deactivation of features or changing of licenses is completely done using the OPC Ua protocol. Yeah, so let me show you what's available today. So we have out-of-the-box solutions that integrate in unified automation SDKs for the ANSI-C-based OPC Ua SDK, as well as for the high-performance OPC Ua SDK. There's several projects, evaluation projects that are using this technology, and I have demonstrated before the research projects in which this technology is used as well. So yeah, let me maybe hand over the phone quickly to Thomas to summarize some of his major takeaways for you.
Thank you, Oliver. This is really a very exciting time that we are in, specifically as Oliver attested to all the things that they're doing in the areas for supporting Industry 4.0, the industrial Internet of Things. And the takeaway from an OPC perspective is essentially we are really providing a whole interoperable information integration solution that really provides, the ability to move data from the sensor into information right into the cloud. This whole operability that we're doing specifically with all the different organizations that we're partnering with, everyone's looking to play into the world of Industry 4.0 and the activities going around the world with the IIC. And with OPC Ua, it really provides what I call secure, reliable interoperability and information integration across disparate applications and devices without having any need for the understanding of the information models built into the client application. So, companies like Wibu are providing a real strategy and real products that really address the need for multi-platform, multi-vendor interoperability. So with that, I'll turn it back over to Oliver.
Yeah, thank you very much, Thomas. So my major takeaways for you is that security is the enabler for IoT and industrial Internet projects. So without that, it will not work. Second, very important topic for me is that each connected device needs a tamper-proof identity. If you are connecting everything to open networks, it's not enough to have a firewall between your factory network and the office network. You really need a tamper-proof identity for all network devices in that. And further, you should consider that the intellectual property know-how in the flexible production process will become much, much more, because data of the products to be produced in the production process, in a flexible production process, contain much, much more of this know-how. The software, the technology data, all of this need to be protected one time against theft, against counterfeiting, but as well against tampering, because otherwise maybe the products that are produced will not be exactly in the way they should be. And the most dangerous in that part would be if you can't see that immediately. Imagine in a car manufacturing factory, the thickness of the painting of the car is manipulated. You will not see that immediately. Yeah? The car comes out with the right color, it looks good, everything is fine, but you might get damages after a short time. So production of all these things becomes very important. And OPC Ua, which is much, much more than secure communication and is further an open standard, that is one key to realize all that in new smart factories, and to do that in an interoperable way, that devices, machines, and from different vendors can really work together in a secure way. And that's definitely important and something you should look at. So thank you very much at this time. And I would like to hand over to Daniela. I'm sure there are several questions from your side.
Yes, that's correct, Oliver. We have a very active audience today. And I would like Thomas to start first and reply to the following. You said OPC Ua is platform independent and can be embedded in small devices. Are vendors building products with OPC Ua inside in the embedded world?
Yes, we're seeing a widespread adoption of the OPC Ua technology in devices deliberately. Many of our trade shows, all the vendors are vying to get on the wall, embedding a whole set of different devices. So from I/O devices and gateways and DCSs and smart meters, they're all UA is being embedded as a fundamental part of each vendor's architecture.
Thank you, Thomas. There's a second question for you. How do OPC UA products work with OPC Classic products?
Okay, specifically, and the whole concept is the classic products, which are a huge installed base of those. Many of our vendors, as well as the foundation, provides gateways and solutions that allow OPC UA to talk directly to the classic products. Obviously there's some functionality that classic doesn't provide, but you can build an OPC UA client or an OPC Ua server to directly interact with its corresponding classic product. And this just works seamlessly out of the box. It discovers the capability, and the data and information can be easily accessed from classic applications and devices.
Thank you. Oliver, now your turn for an answer to the following. OPC UA is an interoperable standard. This is clear now. Can I use a proprietary technology to store my certificates and keys?
Yes, of course, you can do. OPC UA defines on the top level how the security profiles and the protocols work, and that is an open standard that is public, and everybody can implement it below how he stores his certificates. That's the responsibility of the device manufacturer or the manufacturer, the device manufacturer. So he can simply store, and that is what's today done still in the most cases, the certificates and the keys in a file or in a place of the flash memory in the device, and then use with the crypto algorithms with OpenSSL, for example, use to calculate the encryptions and decryptions, doing the signing and so on, using that. And on the other side, if you store the certificates in a secure element, like our CodeMeter technology integrated in an OPC UA SDK, that then you have the proprietary implementation on the downside, but keeping the full compatibility with the open standard, keeping the interoperability. So that's possible, and that makes sense.
Thank you, Oliver. Now back to Thomas. You said earlier that OPC UA has connectivity to the Microsoft Azure cloud. Does it also work with Amazon Web Services, Google, and Oracle?
Part of our architecture, what you're going to see is they've actually tested with Oracle already. We're currently working with Amazon Web Services and Google, as well as a number of other vendors to build, OPC integration to their respective clouds. And if the vendor doesn't do it themselves, there will be other people that are already doing it. So next year you'll see at our big trade show in Germany, we're going to have connectivity to each one of those that you mentioned, including Amazon, Google, and Oracle, and it's exciting.
You really sound so. One last question for you, Oliver. You shown CodeMeter integrated in an OPC UA SDK. Can I use the secret certificate storage and IP protection at the same time?
Yes, you can. So that's one of the USPs of CodeMeter as well, that you can store in one secure element, in one so-called CodeMeter dongle, certificates, keys, licenses from different vendors, and they are completely independent from each other. So the question is definitely yes, you can do IP protection, licensing, and certificate storage with one device. So that gives the multiple value for vendors implementing that in their devices.
Thank you, Oliver. Before we close, one last question to Thomas as well. What is the vision of the OPC Foundation for the future?
So my vision is to continue working with all these organizations and managing all the technology innovation that's out there. We've got a very driven board, including companies from Honeywell, Yokogawa, Microsoft, and SAP, as well as other companies they're all really working hard at bringing products that work together in a multi-vendor, environment. So we're going to continue working with all these organizations to be the infrastructure for all of the initiatives of the Internet of Everything. And it's a lot of work, but we've got a really strong OPC community that's really working hard at building and deploying products into the marketplace, including Wibu-Systems.
Yeah, thank you very much, Thomas. Yeah, thank you. Do we have more questions, Daniela?
No, we're done. I think we've covered all, and I think that there's just a couple left, but we will go back to any last question privately, because we are already at the top of the hour.
Okay, then let me say thank you again for Thomas providing his information about OPC Foundation and the technology and the architecture, and thank you for all the participants in our webinar for your interest, and we are ready to answer all your remaining questions at a later time. Please feel free to contact us at any time, and for today I wish you a successful rest of the week, and Merry Christmas and all the best for the new year.
Thank you, everyone. Thanks for a great presentation by Wibu-Systems and hosting this webinar. Have a good day.
Thank you, Thomas, and thank you, Oliver, for the very interesting conversation, and a special thanks to all our attendees for joining us today. We hope you enjoyed this session as much as we did. Please look forward to our email with a link to the recording and the slide deck in a couple of days. That's all, folks, for today. See you next year for a new engaging masterclass series. Have a bright day and our warmest holiday season's greetings to you all.